Hello, and welcome to this Tungsten Cluster Masterclass training session, where we take a look at maximizing performance with parallel apply. My name is Chris Parker, VP of Customer Success here at Continuant. In this session, we'll explore how the Tungsten replicator can process transactions concurrently instead of one at a time. It's a huge gain for high volume environments. By the end, you'll understand what parallel apply is, when it's appropriate, how to enable it and tune it, and finally, how to monitor its performance in real time. So what is the challenge? Well, in a standard configuration, the replicator applies transactions sequentially, one after another, in a single thread. That's fine for moderate workloads, but when you're moving millions of rows per hour or replaying large updates, it quickly becomes a bottleneck. The apply stage, rather than extraction or network transfer, often becomes the limiting factor in total replication throughput. Parallel apply is an important technique for achieving high-speed replication and curing replica lag. It works by spreading updates to the replicas over multiple threads or channels that split transactions on each schema into those separate processing streams. This in turn spreads I/O activity across many threads, which results in faster overall updates on the replica. In ideal cases, throughput on replicas may improve by up to 5 times over single-threaded MySQL native replication. When parallel apply is enabled, Tungsten Replicator divides the incoming event stream into those multiple apply channels. Each channel handles its own queue of transactions that relate to a specific schema. Transactions that fall entirely within a single channel can run in parallel with others. However, if a transaction spans multiple schemas, it's applied serially in a single channel to preserve data consistency and transaction order. In other words, Tungsten doesn't apply transactions blindly in parallel. It respects those object boundaries. The result is higher throughput for workloads that update independent data sets while maintaining correctness for those that overlap. In summary, if your database has multiple schemas and transactions do not cross schemas, then parallel apply will provide massive performance gains. So to carry on with that summary, parallel apply shines when transactions are naturally independent. You must use row-based logging to ensure the replicator can correctly identify and distribute the transactions. It works best with multiple schemas and, most importantly, transactions that do not span across them. There are additional overheads at the OS level that should also be considered, ensuring the host has the power to process the workload and enough memory in the OS page caches. So when not to use it, well, it's not a universal solution. So let's summarize when parallel may not be the most appropriate choice. Firstly, if you have only one single schema for your application, or you may have many schemas, but only one is the hot or active schema, whilst the others may only have 2 to 3 updates per day, parallel apply won't really give you any benefit in those situations. If your workload has many small interrelated transactions, like typical OLTP workloads, again, parallel apply can introduce more overhead than benefit when they start crossing those boundaries of schemas. When strict commit order matters for auditing or external triggers, parallelism can complicate that tracking. So in those cases, it's safer to remain single-threaded or limit parallelism to certain schemas only. I don't cover locking parallel to specific schemas in this session, but our online documentation has plenty of information that explains that process. So parallel apply can be harder to debug, and it does require those additional considerations to your processes. This additional responsibility may not be suitable for everyone in every situation. So how do you configure parallel apply? Firstly, you enable it by adding the following 2 parameters to your INI file. So that's the svc-parallelization-type equals disk, and then you set the value of channels to a number. So on this example here, nn is the integer value you set it to, which is the number of channels that you want to configure. If you leave that value at 1, that is the default, and that effectively disables parallel apply. What I recommend is start small and test and gradually increase the number of channels to find that correct balance for your workload. What is really, really important though is if you are changing or enabling or disabling parallel apply, always make sure that you take the replicator offline cleanly first. And by that I mean issue the trepctl offline command. Allow the replicator to cleanly come down and balance itself out, and then do the changes and the updates. It's really, really important to make sure you do that first. So further deployment and tuning, as I said, start small. So start with 2 to 4 channels and benchmark, start conservatively. Measure the throughput and latency before you start scaling up. Ensure your target database can handle concurrent writes, especially for I/O bandwidth and locking contention. The sweet spot often comes from balancing apply concurrency with database resource limits rather than simply maxing out those threads. The other one is to monitor the serialization count to see the effectiveness of parallel apply. So what is serialization count? Well, this refers to the number of transactions that the replicator has handled that cannot be applied in parallel because they involve dependencies across schemas. For example, a transaction that spans those multiple schemas, we have to serialize it so that we don't cause an out-of-order update with respect to the transactions that update a single schema only. You can detect the number of transactions by looking at the serialization count parameter. So you can issue the trepctl status name stores option as shown here on the screen, and that will give you an output similar to the example here. This example shows that the replicator has processed 1,512 events, that's the value of event count, and of those 26 were serialized, that's the value of the serialization count. Calculate that as a percentage and it shows 1.7% of transactions in this example were serialized. Generally speaking, this isn't a set rule, but generally speaking, if that percentage is greater than 2%, then you're probably not going to start seeing the benefit of parallel apply. So this is part of your trial and error. Enable it, monitor this, keep an eye on the serialization count, work out those percentages. And if that value is getting up there in the high figures of the percent, then you're probably going to lose those benefits. So further monitoring, the trepctl status, we've covered this in many training sessions before. This just gives you the general status of the replicator. When parallel apply is enabled, there will be a property in that status output called channels, and that will be a value that's greater than 1. That indicates parallel apply is enabled. Additionally, the options of -name shards and -name tasks will give you further information. So the shards option will give you an expanded output showing the number of transactions for each shard or channel. And the name tasks output shows a lot more expanded detail, and it will give you sequence number, progression, latency, etc. per channel. The trepctl perf output, if you have parallel apply enabled, will give you a more tabular version. It takes the values from name tasks, name shards, and it puts that output into a tabular format for you, so it'll be easier to digest and read. What's important to note is when parallel apply is enabled, if you're looking at just the basic trepctl status output, there will only be one value of applied last sequence number. In the regular trepctl status output, that value is the minimum recovery position across the apply channels. So what that means is it's the position where the channels restart in the event of a failure. It's quite conservative and it may make replication appear to be further behind than it actually is. So when you've got parallel apply enabled, you really need to rely on the name tasks output. That will give you a more accurate reflection of latency and progress on a per channel basis rather than that summarized version that you would get in the basic status output. So what have we covered? We understood what parallel apply means, how it works, benefits, use cases, important limitations, and there's best practices for monitoring, configuring it, tuning it, and obviously how to understand those status outputs. So it was a short course, but I hope you found it useful. And I'm sure that if you find that your use case would benefit from parallel apply, then I'm pretty confident that if you apply it, pardon the pun, if you apply it, you will actually see some really good benefits in that apply performance. But if you do need any assistance, any further information, then please do not hesitate to reach out to myself or the rest of the team via your usual support channels, and we'll be happy to help you put this into practice. So thank you for your time. Thank you for listening. And I hope to see you soon on a future training course. Take care, thank you, and goodbye.